the Rosetta mission landed a probe on a comet 500 million kilometres from Earth. In the year that followed, the Rosetta spacecraft streamed back mountains of data from comet Churyumov-Gerasimenko, also known as 67P. And the scientists back home have made some amazing discoveries. Rosetta scientists were expecting a dull potato-shaped comet. What they got was a dusty ice ball shaped like a rubber duck. So how did it end up like this? Photos of eroded patches on the surface revealed onion-like layers of dust and ice. These concentric layers surround two different centre points, one in each lobe of the comet. This suggests that the comet was formed from the collision of two smaller fragments, hence its peculiar shape. Huge jets of gas pouring out of the icy comet give clues to its age. Rosetta has been able to analyse the different gases in these jets, many of which would have been trapped inside from when the comet first formed. The way the gases are released, all mixed together, point to the comet being made of a certain kind of ice. This could only have been formed in extremely cold conditions, perhaps even before the solar system began. This is just one of a number of observations which hint that 67P may be very old indeed. Comets are mostly made of ice, and there's a long-standing theory that it was comets that brought water to planet Earth. But the water vapour coming off 67P isn't like ours at all. Compared to normal H2O on Earth, a lot of the hydrogen atoms in 67P's water have an extra neutron, making them deuterium. The ratio of hydrogen to deuterium doesn't match Earth's at all, meaning that wherever our vast oceans came from, it wasn't comets like 67P. A year's worth of data from Rosetta has answered a lot of questions, but the mission's not over yet, and there's plenty still left to learn. Like snow, and finding it could change previously studied a comet called Hard. Finding it could change our ideas about how the solar system formed. Scientists had previously studied a comet called Hartley 2, which is in a similar orbit to 67P. But the water on Hartley 2 has a very different ratio of deuterium to hydrogen compared to the water on 66 places. Before its journey ends with 7P.